And this is kind of an experimental tutorial. It's about learning Python, but not through like a hello world program or Fibonacci numbers, okay? So it's basically going to combine sort of a learning Python tutorial with some public data hacking examples. And just to help me out a little bit, I don't know what experience with Python people have in the audience here. And not to put anybody on the spot, but I would be sort of curious, how many of you feel that you're sort of new with Python, kind of sort of new with Python? Okay, about two-thirds, okay. Is there anybody who's never done anything with Python at all, like never started it? One person, okay. It's your responsibility to help him out there, okay. So, it's good that everybody has done that. The version of Python for this course, everything should probably work with 2.7 or 3.3. I'm going to use 2.7 just because I'm going to do some plotting later, and the tools are installed a little bit better for that. Again, there are some support files kind of going around on USB key. There's not a huge number of support files, just so you know what that looks like. Let me sort of find the files here. You should have a folder. It looks like Learn Python Data. There should be a code directory. There should be a data directory. PyData hacking is the presentation notes. So if you want to look at the PDF of what I'm going to present, that's where you'll find that there. And then that's about it. I'll talk about what's in there as we go, but that's what's on the USB key, and you'll need that. As far as what the tutorial is going to cover, it's basically two topics: learning Python and hacking some public data. The primary focus is on the Python side, just to be absolutely clear about that. I mean, it's like the title of the talk was learning Python, not learning data, okay? So it's about learning Python. We're going to do a lot of coding. Later on in the tutorial, I'm just going to let you loose for like half an hour, 40 minutes. We're going to code on like some hacking problem involving data. I think you'll have fun with that. One note, it's the focus of this tutorial, again, is not on data science, okay? So we're not going to be doing statistics in here, or GIS, or advanced math, or Hadoop, or anything like that. I mean, this is not like a big data tutorial, basically learning Python. And we are going to do a fair amount of coding, so do introduce yourself to your neighbors, like look at who's sitting next to you, work together when we get to the coding section. And then your responsibilities here: ask questions. Don't be afraid to try stuff out. I might actually, put a little bit of a burden on you in reading the documentation. I don't want this course to be a reference manual on Python. So I'm not going to sit up here and tell you like every single possible thing about everything, okay? It's, you might have to look a little bit at the docs. And then get my attention if you're stuck on anything. I've also got a couple of assistants. Brian is in the back, sort of standing back there. We have Jake. Is going to do some stuff as well. So ask questions. And so why don't we just go ahead and get started with it. So the first thing that I want to do is just get some basics out of the way to start. So the first thing is just running Python. I mean, hopefully you've figured this out at this point, but to run Python, typically run it from the terminal. You just type Python, get a prompt, you can start typing commands into it. If you are on a Windows machine, how many of you are using a Windows machine in here? I would probably advise, unless you have some alternative on there, to use idle to get started. I mean, unless you have some other environment installed, because otherwise you're going to have to run Python from the DOS, like the command prompt, which sort of sucks, actually. Okay, so if you're on a Windows machine, you should just be able to go to like the Start menu. If you have Python installed, you should be able to just find the idle program, run that, and it will bring up the Python interpreter for you. And you should be able to do pretty much everything in this class just from the idle interpreter. Okay, took a little while to come up there, but you'll get this terminal. You can type commands into it, do math calculations and so forth. Okay, so Python basically, if you're new to it, is an interpreted language. It executes what you type. You have this interactive mode. Very fun. If you've been playing with Python already, you should know this, or you should have seen this. Some things about that interactive mode. It does just sort of run what's known as a read-eval loop. It's actually one of the coolest things about Python is that you can actually experiment with it. You can fire it up. You can type commands into it. Just do immediately what you type. I think it's one of the neatest features of the whole language is that you can just do this interactive exploration with it. A few little notes about the interactive mode. Triple greater than is just the prompt, Python telling you, hey, type a command. If for some reason you get triple dots or blanks and it's not doing anything, it usually means that it wants you to keep typing what you started. It's like saying, oh, well, you're on it's multiple lines, you need to keep typing. You do that and then you hit a blank line to get it to run. As far as creating programs to run later, all you need to do is just create a .py file using whatever your favorite editor happens to be. I mean, hopefully it's called Emacs, but if not, you're giving me a look, Brian, with the... Okay, yeah, it could be something other than Emacs, but just make a file with whatever editor you want to use, and then to run a program, you just run Python on it. You basically say Python hello world.py runs your program, okay? And that works on Windows, works on Unix, and so forth. One little pro tip that I'm going to leave you with for exploration. I'm a big fan of using the Python -i option with a program. Like you edit a program and then you run Python -i on it. That will actually run your program and then drop you into the interactive term, like the shell, and then you can mess around with it. Very useful for debugging and doing things like that. So if you haven't seen that before, that's actually a very useful technique on Unix machines and so forth. If you're going to use the idle tool, just a note about that. It's a little bit unusual, but typically what you do with that tool is you will make a program by kind of coming up here. You basically say, hey, I want to make a program, file, new window. You get a new window where you put your code in here. Okay, so there's some Python code. In order to run that, what you need to do is basically save it as a Python file. Okay, so you're going to do save as. It will sort of prompt you for a file name. Go up here and just say, hello.py. And then in order to run that, and this is kind of the unusual part, you need to find the run button in idle and then come down here and click run module. So that will essentially run the program, and you'll see the output in the terminal window there. So it's a little bit different than what you would do just running it on like a Unix machine or something like that. But if you are going to use idle, that's how you do that. And so that's some basics of making programs. Now, what I'm going to do next, let me just see if there's, I don't know, is everybody okay with kind of running Python and starting it up? I would assume so if you've seen it before. What I'm going to do next is a very, very, very fast Python 101, because what I want to do is get through some basics and actually have you write some code for something more interesting. So let's just let's get a few basics out of the way. First of all, the structure of a Python program is just a bunch of statements, one after the other, terminated by new lines. The way that the interpreter works just starts at the top of your file and goes top to bottom. And when it hits the bottom of the file, that's the end of your program. So it's very much like a scripting sort of model. If you want to have a comment, use a £. If you want to assign a variable, just assign a name to some value, like height is 442 or name is Dave or something like that. Okay, so just a variable name and a value. If you come from other programming languages like Java or C or something like that, you don't declare types. So you don't say like it's an integer, or you don't say that it's a float or anything like that. The value basically, or the type basically comes from what you assign it. Like 442 is an integer, for instance. There are some basic data types that you work with in programs. For numbers, there's basically integers and there's floating point. How you would specify that in a program is just with the decimal point. So if you don't have a decimal point, it's an integer. If you do, it's floating point. If you want to work with text, you just enclose text in quotes, either single quotes or double quotes. There is no difference between single quotes and double quotes. So use whatever style you're happy with, basically. So there's two different quoting styles. None is something that you'll see as a placeholder. It just means nothing. It's like, oh, this is a variable. It doesn't have a value of interest right now. So those are some of the basic types. If you want to do math, Python behaves normally. I mean, we could talk more about that, but Python is not violating like the rules of algebra or anything like that. Okay, you just do normal math operations. There is one potential gotcha for doing data calculations, which is the fact that integer division truncates. So be a little bit aware that if you're doing any kind of calculation, like 7 divided by 4, it's going to drop down to 1 and not give you 1.75. So that's one little caution. If you want to do text manipulation, generally what happens with that is you make a string, and then there's operations like len and plus and upper and starts with and replace and so forth. Just as some maybe an interactive example of that. Well, I don't know. We'll stick with Windows here. Why not? Okay. So let's say you had a string like "Hello World," for instance. If you wanted to do things with that, len will tell you how long it is. If you wanted to add something to it, like add an exclamation point, you just use the plus. We'll like add a character to it. There are various operations, like you can uppercase it. You could replace things, like you could say replace hello with hello cruel, for instance, and so forth. So strings basically have a bunch of these operations. This course is not really going to be a quiz about the 3 dozen things that you can do with strings, though. So this is just sort of a taste of it, of what's available. Basically doing string manipulation. Sometimes you need to convert values. This is actually a slide that is actually, it's actually critically important for a lot of data analysis stuff. If you want to do like math calculations, you have to make sure that things are of the right type. Just to illustrate that, let's say you had x was equal to 42 in quotes. Okay, this is a text string. And then let's say you had y was equal to 13. You can't add those together. Okay, because one of them is basically a string and the other one's an integer, and it's getting very confused by that. So if you want to do anything, sometimes you'll actually have to do conversions. Like you'll have to convert one of them to an integer and then do math with that. Just as a quick question regarding fonts, by the way, how's the readability back there in the corner? Is it like, okay, could be a bit better maybe, okay. I'll sort of bump it up when we get going into the code stuff. So you might have to do some conversions. And then some other things in programs. If you ever want to do a conditional, just use if and else for that. Okay, pretty straightforward. That you see that in most other programming languages, if and else. If you want to do relations, it's just less than, greater than equal. Same kinds of operations that you have in other programming languages. If you want to do Booleans, you just do and, or, and not for that. Okay, so those are some conditionals there. If you want to do looping, there's sort of 2 constructs for that. There's a while loop, which basically just executes in the indented statements under there as long as some condition is true. And then there's a for loop, which is used to iterate over data. Okay, so this is like if you have a list of names or something like that, the for loop will process those one at a time, going over data. Just a few notes about some of these things like conditionals and loops and so forth. You will notice that Python uses indentation to basically denote code blocks, like the statements that are going to execute. Just so you know, the amount of indentation does not matter. However, at this conference, you'll be bludgeoned if it's not 4 spaces per level. So, typically what you do for indentation is use spaces, don't use tabs, use 4 spaces per level. If you use an editor that knows about Python, usually it does this for you. Okay, so that's the indentation rule. For doing output, use a print statement. Well, produce output. This is one big change between Python 2 and Python 3. If you use Python 3, print changes into a function. So be aware of that if you're going to use that. And then a few little final odds and ends. If you want to work with files, which we're going to do actually a fair amount in this class, you use the open function to open up a file. Okay, so you say, okay, I'm going to open up some file for reading or writing. To read or write data, there's a read method and there's a write method. Read will basically just take the entire file and just grab it and put it in a text string and then hand it back to you. Write will basically take data and just write it out to a file. Another idiom that's very, very common with files is reading one line at a time. Typically you do that by opening up a file. You do a for loop on it, and then you just go line by line. It'll basically read that until you get to the end of the file. So those are some idioms with files. And then a couple final things. Sometimes you might want to define a function. to do repeated operations. If you want to do a function, you just use the def statement. You say, okay, def, name of a function, some input arguments. This becomes something that you can then just use in your program. Okay, you just use the name of the function, and it will just call that and return some data back. Believe it or not, this is about the only thing I'm going to say about functions in this class. It turns out that functions, for the most part, are actually quite uninteresting in Python because they actually work normally. Like, they behave in a sane way in that, like, they have, you know, like variables there's like local variables that are hidden, and the naming works and all this stuff. You just don't worry about them a whole lot. But this is how you define new function, basically, with the def statement. And then if you want to use built-in functions, there's basically an import statement that is used to load library. So Python actually comes with a large library of code for doing things like math and reading from the web and doing data analysis, that sort of stuff. So the import statement is what you use to do that. Now, having gone through that review, I would much rather actually work on a coding challenge. Now this is kind of the primary focus of this tutorial, is to actually have you code on some things. So the thing that we're going to do here, we're actually going to work on sort of 3 separate projects or little coding things in this tutorial. And the first one that we're going to do is something I'm calling the traveling suitcase problem. And this is actually inspired by a true story, which I'll explain in a second. But here's the problem. So this is a Chicago-themed story. So the guy in the picture there, that's Travis Oliphant, who, if you don't know who he is basically the creator of NumPy, very popular library in Python. He came to visit me in Chicago about a year ago, took the bus up to my office, got off the bus and left his suitcase on the bus. Now, leaving your suitcase on a Chicago city bus and having it drive away, you basically just assume that, yeah, okay, that it's gone. Forget about it. You know, you're never going to see that again. So he left it on the bus. Now we actually got it back, but it was an unusual approach. So this is the first problem that we're going to look at, is basically getting the suitcase left on the bus back. And the first thing that I'm going to have you do is sort of a panic coding here. I actually want you to start up Python. I want you to type this code in exactly as it appears and spend about 5 minutes doing that. I'll tell you what you're doing right here. You're actually going to the City of Chicago Transit Authority site, and you're doing a real-time query on that bus route and getting a snapshot of the route, along with all the vehicles and GPS coordinates. So just take about 5 minutes to do that. I'm going to walk around and just sort of see what's going on, see if anybody's having any trouble with that. Actually, maybe I will do the exercise myself real quick. Okay, you got some of the keys. Does anybody need the USB keys? You guys need them? That code, by the way, is in the notes that has been passed around, so do you need one? Oh, okay. 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 You don't want it cut off on the okay. This will also be your check to see whether the web is working. If the web is not working for people, let me know. There's a backup plan. So. turns out that most cities out there, at least the big ones, are publishing APIs for their transit systems. This includes things like the bus system, subways, trains, that sort of stuff. The thing that we just looked at is basically from the Chicago Transit Authority. They actually have a website for developers. If you go to this website, transitchicago.com developers. Actually, let's go ahead and do that. I'm going to do some demos of stuff. You go there, you'll actually find quite a bit of information, like a whole developer center. They'll talk about sort of the API, different things that you can get. A lot of this stuff is all real time. It's like real-time tracking of things. You can find out like schedules of things, where things are. Transit alerts, that's actually a big thing. Like if there's like a big accident somewhere in the city, they'll publish alerts saying that traffic's being rerouted and so forth. So cities are sort of publishing this data. And that's actually what I had you access in this in that example, was basically some of that data. Real time, has GPS coordinates, has stop predictions, things like that. People are using this data basically to build apps. A lot of times like mobile apps. We have this thing in Chicago, the CTA bus tracker, where you can, like if you're standing next to a bus stop, there's like a number on the bus stop and you can like punch it into your phone or a web app, and they'll tell you things like stop predictions. You can see where things are going. So it's pretty cool. The data that you're getting back in this is essentially some XML. Okay, so you have some XML, and inside the XML, there are certain things of interest, like vehicle identifiers. There's what direction the bus is going, what are the latitude, longitude coordinates of it, and so forth. There's actually even some stuff in here that's sort of questionable. As far as I know, this op field, you can kind of see that down at the bottom. There's like op, is actually the employee ID of who's driving. I don't know whether the bus union knows about that, but it's like operator IDs. If you were so inclined, you could like query the transit system and do statistics on things like who drives really fast based on GPS coordinates and all sorts of stuff. So a lot of interesting data in there. So what we're going to do now is actually try to solve this suitcase problem. So the very first thing that we're going to do is we're actually going to look at that XML file that we just read, and we're going to try to find all the vehicles that are going north of my office. Okay, he just took the bus north up from downtown. He left his suitcase on the bus, and the bus went traveling north, onward. So we're going to try to find everything north of my office, like vehicle IDs. Try to narrow it down and see if we could figure out what bus he was on. This actually happened when he did this, by the way. I actually fired up the CTA bus tracker app on my phone, and I looked at things on the map and got vehicle numbers. And I said, well, you were probably on bus number like 1822 or whatever it was. And we sort of got that information. And then what we're going to do is try to figure out if the bus comes back to my office. This is actually the approach that we took with Travis. The first thing that he did actually is he called lost and found with the bus system. Bad idea, right? Okay, he called up lost and found. They're just like, well, if it's still on the bus when it gets back to the garage, maybe you'll find it. The only problem is we don't know when it's going to come back to the garage. It could be like 16 hours out on the road or something like that. So, the alternative is basically to monitor the bus system, see whether the bus actually comes back in the direction of the office. Like maybe it's just doing like up and down routes, up and down the street. And then if it comes within the office, we'll just go out there and grab it off the bus. This is actually what we did with Travis. Actually worked. Only in the case of him, his suitcase rode around Chicago for 8 hours, unattended on the bus. I sort of find this kind of startling, actually. It sat up there by the bus driver, unattended for 8 hours, got a huge tour of the city, and then sort of came back by the office, and then we picked it up. They also didn't say anything when we just walked onto the bus and grabbed the suitcase and walked off. The bus driver is just like, yeah. Okay. So that's what we're going to do. Now, in order to do this, a couple things I have to have you do. I have to basically have you parse some XML. To do that, there's this library element tree that you can use. So you say from XML etree element tree import parse. You point it at an XML document. You just say parse it. What that will do is turn it into a document tree where it kind of splits it up into different elements. Like in this bus data, there's basically all these like bus elements, one after the other. So it will sort of parse it into that. And then what you'll typically do is do like a little for loop where you'll say, okay, for bus and doc find all bus, this will essentially iterate over these like bus elements one at a time. So it's going to go through the document. It'll sort of say, okay, you know, we're going one at a time over each bus. And then for each of those, you can essentially pull data out of it by using these things like find text. Well, actually, you can just do find text. So you can say, okay, give me the direction that this thing was going, or, you know, give me the latitude coordinate of the bus. So that's what we're going to do. If you want to do anything with a map, actually, one of the things that I wanted you to do in the challenge here is if a bus actually got closer than half a mile to my office, I wanted you to pop it up on a map on a browser with like a pin on it so that you could actually see where it was. If you want to do that, there's a lot of options, but an easy one that I'll have you look at is maybe the Google Static Maps API. You're gonna have to look at the documentation a little bit for that, but it turns out that it's actually quite easy to just fire up a browser in Python. You can just use this import web browser, you point it at something and it'll pop up a browser. So you'll get something like that. So what I'm gonna have you do is code on this for about 30 minutes. Basically the challenge is to take that data that you just downloaded, first of all, try to figure out what bus that Travis was likely on based on like positions on the route. You're gonna go on there and you're gonna say, okay, well he just left it on the bus about 10 minutes ago, basically. Or we made that snapshot right afterwards. We're basically going to look at that and just look at coordinates. We're going to say, okay, well, which one of those was he likely on? And then what we're going to try to do is basically real-time track the thing and see if we can find out where the bus is right now, if there's any hope of rendezvousing with it shortly. So I'm going to have you work on that for about 30 minutes. Talk to your neighbors. I'm going to code up little bits and pieces of it as we go, sort of off and on. It is a little bit of a challenge, but it's not a lot of code, actually. So take a look at that. The index card does have a sample of parsing some XML data on there. You can use that as a reference here. Okay, so work on that for about half hour. I'm going to walk around. I'll see what people are doing, and I'll start coding myself in about 5 minutes. Actually, do you have some questions here too? Okay, so the question is about the data itself. The data that we pulled down is basically for a specific bus route. Okay, so there's like in the city, there's maybe like 100 different routes of buses because Chicago is big, right? I mean, there's a lot of different bus routes. We basically pulled the data down for a very specific route, which is Route 22. Yeah, it's basically Route 22 buses. Now, at this time of day, I mean, right now it's like probably about 3 o'clock, 3:30 in Chicago. I don't know how many buses are on that route, but I would guess that it's probably on the order of 20. I mean, it's a big city. There's like lots and lots of stuff going up and down the street. So we basically downloaded maybe 20 buses just specifically on Route 22. If we took a snapshot, actually there is a way to get a snapshot of the entire system all in one shot. I mean, if you're interested in that, I can give you a link, but if we were to download that, it would probably be like 900 buses. I mean, it's a much bigger XML document, maybe 900 to 1,000 vehicles out on the street, so. Yeah, questions over here. If you get an HTML document, you have a typo in the URL that you pulled down. What happens is if you have a typo, it returns basically like an error, like maybe like a 404 error along with a message, and you've actually gotten the message from that. So. Yeah, double check that URL basically. So yeah, if you got HTML down, it means that you probably have a typo in the URL. So, yeah. For this part of it, I would recommend writing a file. Yeah, definitely. So, because you're probably going to want to tweak it and make changes to it and so forth. So the thing that we're going to do here is we're basically going to write a file that's going to try to find every single bus traveling north of my office along Route 22 here. Let's see, how are you guys doing over here? So latitude is going to be north-south, and then longitude would be east-west. So we're actually only going to work with latitude, probably. Right. Yeah, latitude greater than 41. So. Yeah. Oh, that's interesting. Did anyone get like a broken XML document at all? Check this out, Brian. The document that I actually got downloaded from there is a broken XML tag. We're gonna blame that on we don't know what their site is written in or why we would have done that. ASP probably, yeah. You want to raise the browser when any of the buses that you've identified as a possible candidate. There's a little bit of judgment call on this, like. Yeah. So yeah, the code that you're writing, it's gonna essentially there's a couple of things that are going on. You're looking through this XML document. I'm going to get the latitude first, and I'm just going to say, first of all, is it north of my office? If it's not north of my office, it's not even in consideration. Okay, so forget about that. So we're sort of saying, okay, is it north of the office? Then what I'm doing is I'm basically saying, okay, give me the direction of this thing. That's what the D element is. And I'm just going to see, is it actually traveling northbound? Because I don't care about things that are coming the other direction, north of my office. It was like he wasn't going southbound, so I don't care about that. So I'm basically saying, well, if the direction starts with any variation of north, like could be northwest, could be northeast, could be north, but going north of the office, I'm gonna find that. And then if I find a match, I'm gonna find the identifier of the bus, which is basically a number like printed on the side of the bus, and then I'm gonna print that out along with the latitude. If you've done this, you should get output that looks something like that. I got 2. I don't know whether you got 2 or not. I mean, considering we all did this at kind of approximately the same time, you'll probably get something like that. So what I've got here is basically 2 different vehicles. I've got like bus 1865 and 1383. This might be a bit of a judgment call. I mean, you could sort of say, well, okay, you know, if he just got off the bus, it's probably the one closest to my office that he was on. It might be that 1865. We're not really sure. Maybe you want to track both of them, but that's what we're looking at. Did anybody get different answers than that, or you want to see the code again? Let me put the code up. Yeah. So like the element is the bus, and then you use that to find things inside of it. So yeah. Okay, for the monitor part of it, this is a very, very rough ballpark, but I'm asking you basically to find the buses when they get within like half a mile of my office to basically do an alert. This is a really, really gross approximation, but if you take the difference between two latitude coordinates and multiply it by 69, you get approximately the distance in miles between that. Now that's not actually accounting for longitude, which is like east-west direction, but we can actually get away with that here because this bus route in question is basically a north-south street. So the bus is like, they're not really deviating in the east-west direction. We're only focusing kind of in the north-south direction. So, so if you want to do a distance calculation, do that. And we actually saw these things kind of on a map, and we're just like, well, which one was he probably most likely on, based on like how far they'd gotten from my office in the time that it took us to sort of realize that he'd forgotten it and queried the system. So, you know, that might be kind of, you know, you kind of have to make like a judgment call on that. Maybe monitor both. Maybe just monitor the one that was closest to the office at the time you pulled the data down. So, like here, that 1865 was probably the closest one. Maybe that was the one that he was writing. So. Pardon? That does not apply to longitude, because the longitude basically, it gets narrower the closer you get to the poles, right? Because like degrees latitude, they basically all meet up at the North Pole. So the distance east-west gets like, it sort of shrinks the closer you get to the pole, and then as you get to the equator, it's like longer distances. Latitude is more equidistant on that. No, we don't need, well, if you wanted to be completely pedantic about distance, you would use longitude, but since this is a north-south bus route, we're just going to punt on the longitude, just saying, well, it's not really going that far east-west. So. We're not going to use Pythagorean theorem. Actually, if you really want to, if you guys are like really, really bored at the conference and you want something really nasty to look at, actually look at the problem of calculating distances between latitude and longitude pairs. It's actually a really horrible problem. I mean, I think there's something like a Haversine formula, which does it for sort of a perfect sphere, but the Earth is not actually a perfect sphere. It's kind of squashed, and like, if you take into like that sort of count, the calculation actually becomes really complicated. What? Yeah, like geocoding kinds of, or, oh yeah, geode, yeah. So to do the monitoring, let me just talk about that. Keep working on it, but to do the monitoring, you're actually going to do basically the same thing that you did in the start of the exercise, which is I'm going to write some function to basically pull down the data, and then I'm going to basically try to go through that data and see whether any of those candidate buses are in there. And if they are, I'm going to try to find out how far away they are from my office. So. What? Did it work? So you actually got a map, you got the map to fire up? Using the static maps thing? Okay. I'm just watching the time. I'm not sure I'm going to, according to my clock here, I have about 24 seconds left, so, or a minute left. I'm not sure I'm going to get the map stuff to work myself because I've been walking around. You want to see the code again? Yeah, okay. What I've got, what I'm doing in the basically the code that's running now is, let me make it a slight bit smaller so you can see more of it. I have basically a function, this monitor. What it's going to do is it's using urllib, kind of pull data down. Here's the idea. First of all, I have these candidate buses. These are the ones that I've identified as being of interest. I'm sort of saying, okay, those are the ones that I think Travis was on. And then I have latitude coordinate. And then what I'm doing in this monitor thing is trying to get this to center right. Okay, I have a function. Basically, it's going out on the web. It's saying, okay, give me a snapshot of Route 22. Parse the thing, and then I'm going to essentially look at the latitude coordinates of the buses and just sort of compare those to my office there, doing a little distance calculation, and then just print it out. Okay, so that's kind of the idea with that. And then at the end, I'm just putting this into a constant little loop where it's just going to spin like once a minute. Print out the monitor and just sort of see where they are. What I would need to do is for the web part of that is modify it to pop something up. So what you're actually seeing here is the if you're running that, one of the buses, the 1865, actually looks like it's getting closer to my office. And the 1383 looks like it's driving away from the office. So at least, yeah, it went from 0.6 miles to 0.9 miles. So that one probably already passed back south of the office here. All right, give everyone a few more minutes on that. It's real-time data. So actually, one kind of thing on maps, by the way. Now, what was I going to say on maps? Well, yeah, just watch that for a few more minutes here. Why do we need the candidate buses at all? One of the reasons I'm doing that is that at a typical time, there might be like 20 buses driving on Route 22. And I don't want to go out and meet like every single one after the other, every single time they come by my office, because I'd be constantly going out to the office. So I'm kind of the idea is, I took that initial snapshot just to see, well, what was closest to my office at the time he left the suitcase? And then I'm just going to focus on like either those one or two buses as they kind of follow through the system. Yeah, that looks okay. You got like B basically. Yeah, okay, good. that little spot, like if you saw them cluster kind of at the top, there's like a turnaround point up there. Yeah, so. All right, we're going to move on from this in a second. All right, well, I'm gonna move on a little bit. The thing with this bus example, as I mentioned, Travis's suitcase rode around the CTA for 8 hours up by the driver in the front of the bus. We have plenty of time to make, if you haven't found the suitcase yet, you can keep working on that. Yeah, it'd be basically these buses, they just go up and down Clark Street, driving like probably about 10 miles in one direction. They just sort of go up and down all day. I mean, it's possible that the bus will switch over to another route or go back to the garage or something, but that's, yeah, question over here.
Is there a page that is a source for constantly updating data like this? I mean, the Transportation Authority, or MTA, that seems pretty good. Are there any others?
I mean, just generally, or? I don't know whether there's like a general one. I mean, like for any city, or?
No, is there some sort of index saying, hey, here's a good, to do these sort of things in other domains?
Oh yeah, I don't know. That's a good question. Like almost like a master index linking to different.
Like flight tracker?
Yeah.
XML
Yeah, you might be able to. Yeah. I mean, actually, the CTA data. If you want more information about some of the stuff that we're doing. Actually, the thing that we're interacting with is the CTA unofficial API. It turns out that the bus tracker was actually reverse engineered, which is how a lot of people discovered these endpoints and sort of discovered that. So there's actually an unofficial API. You can actually get a list of all the different things that are available here, and sort of see like what is available. You can get like a list of the API endpoints. There's actually more things there. Like you can get like information about routes. You can get stop predictions. You can pull like this one here, get buses route all. Actually, will take like a snapshot of the entire system and turn it back as XML. You'll get like 1,000 buses coming back as data there. You can get schedule information. There's actually a bunch of stuff here. It's kind of interesting and fun data to play with. I mean, some of the things that you can do that's kind of interesting if you start bringing in like employee IDs. I mentioned that the data actually has like the operator identifier. You can actually do all sorts of analysis to find out like how many hours people work. Are they running overtime on the bus system? Who drives fast? Who drives slow? One of the things that I saw somebody do with this is they studied the accuracy of GPS signals. This is kind of an interesting one. Turns out that buses always drive the same route. Very predictable route. And they were actually looking at the GPS coordinates reported by the bus and doing like scatter plots to see how they, what the error was on the GPS as the buses drove into like the downtown area. They could actually do like a little thing where it's like, what is the effect of tall skyscrapers on the accuracy of GPS signals? And one way to do it was like monitor buses, which always drive in the same spot on the road, up and down, up and down. You could see they were doing like these scatter plots of like GPS accuracy and stuff. So there's a lot of like interesting sort of hacking that you can do with that. Actually, as another bit of sort of trivia, by the way, the guy who did the unofficial API for the CTA, I guess, I don't know whether it was directly after this, but he got promoted. If you know who Harper Reed is, he was the chief technology officer of the Obama re-election campaign. Okay, so yeah, got a slight job promotion there. Okay, now the thing we're going to do next, let's go ahead and leave that behind. I need to introduce some new concepts. So if you're going to do anything more with data, you have to worry about data structure. like storing data, being able to do things with data. So you might have to, maybe you want to modify this program to start doing things like place markers or something. Like I want to keep like a whole record of like, oh, where are the buses? What are their latitude, longitude coordinates, and so forth. I want to store that in my program. To do that, there's a couple of approaches you can take. One way to sort of build up data structures is to store things in a tuple or tuple. I'm not sure what pronunciation you like. I'll stick with tuple. Basically, tuple is just a bunch of values kind of grouped together. You write them out in parentheses. If you want to know what a tuple is, it's a row in a database. Think of it like that. It's like one record of data has multiple parts to it. Very good mental model for a tuple. You can access a tuple like a little array. So if you make one of these, you can actually pull out data, just using like a little array syntax like that. One little critical thing, you can't modify them though. So if you make a tuple, you can't go in there and rewrite it. It's like a read-only data structure. And the other thing you can do with tuples is unpack them. This is actually probably the more common thing. So you can either access them like an array, or you can build this thing up and then maybe unpack it into a bunch of variables. So you could say ID lat long equals bus, and then it would just put those into separate variables. Probably the most common place where you'd see that is if you were maybe reading database data or something. You would say, okay, here's a bunch of rows of data coming back out of out of a database or something. You're going to store them in variables by doing that unpacking. So that's one way to store data. Another way to store data is to use Python's dictionary type. This is a bunch of values where you just name the values. It's essentially keys and there's values. So you could use syntax where you just say, okay, bus is curly brace, ID is 6541, lat is that, long is that. The nice thing about this is you use the key names to refer to the data. So in your program, you would actually say things like bus ID or bus lat or and so forth. It tends to make code a little bit more readable, especially if you compare it to this. I don't know whether you've seen code like this, but I hate code where somebody would write something like, oh, you just take record 1 and then you add record 10 to it, and then you divide the whole thing by record 15. And if I see code like that, I'm starting to think of my taxes. And I hate my taxes, okay? I hate doing taxes, It's like, and so why do I want to see that in code? I mean, I sort of like dictionaries because you get more descriptive code. Like, oh, I'm doing the latitude plus the longitude or whatever I'm doing there. Some other data structures you should know about. List is basically how you keep a bunch of data in order. So you can make like names. You can say names is Dave Paul Thomas. You can add things to it with an append method. You can get the length of it and so forth. Basically use list if you want to hold a whole bunch of items, usually all of the same type. That's actually kind of an important point. Python does not actually care if you make a list of different kinds of data. I mean, that's actually one very flexible thing about Python is that you can make data structures out of anything whatsoever, right? I mean, you can just come in here and say, well, I want to make a list items that has like a number and a string and a float in it or something like that. I mean, yes, technically you can do that. Most of the time you don't. I mean, most of the time when you're building lists, you put the same kind of data in there, like a list of numbers, a list of tuples. You can put anything you want, but usually it's all of the same kind. Otherwise, your head just explodes at some point. And then the other thing that you can use, dictionaries are actually great for lookup tables. One of the things that you could do, let's say you wanted to build like an app where you're just like, you know what, I'm going to monitor the real-time location of every bus in Chicago. I'm going to build like some database, some server or something that does that. Very easy way to do that is just to build a dictionary where the key is basically your lookup term. It's like your index. Maybe it's like the vehicle number. Like, I want to know where bus 1412 is. Where is it? Use that as the key, and then you just store whatever data you want in there. So what I've got here might look a little bit cryptic, but it's basically a dictionary where the key is the ID of a bus, and the value is a tuple of lat long coordinates. I could use something like that to just do quick lookups. Like I could just say, oh, bus lokes 1307, and it would come back with coordinates of it. Very useful for that. Another data type, somewhat useful, is the set data type. This is, actually I have a typo in the slide here. This is an unordered collection of items here, so let me go ahead and fix that. I don't know, some lack of caffeination or something. Okay, so it's basically an unordered collection of unique items where you can add and remove things. In terms of data processing, it turns out that sets are really, really useful for duplicate detection. Which is, I don't know that it's something we're going to do here, but a common strategy is you would take items that you're looking at, throw it into a set, and then you could use the set to basically determine whether you've already seen it or not. You could say, oh, did I already see that? You do like the in operator, and it would tell you, yeah, true or false, I saw it. So that's one use of those. And so to do some things with data structures, I'm going to give you a new coding challenge. This is sort of in response to the bus system, because riding the bus kind of sucks, actually, okay? It's like nobody wants to ride the bus. So what we're going to do now is we're going to do road biking. Okay, so we're going to do a road biking example. And the problem here is that even though Chicago has this really nice lakefront path, it has become boring to you because it's not enough excitement in your life. You know, it's not exciting enough. So the thing we're going to do here is we're going to try to find the most extreme road biking path in Chicago based on the most potholes reported in the road. Right now it's winter, you know, there's a lot of potholes in the street. So we're going to try to find the route in Chicago. I put it the most post-apocalyptic pothole-filled 10-block section of road in Chicago on which to ride your bike. And you're saying, like, how in the world am I going to do that? You're going to use the City of Chicago data portal. So a lot of cities right now are actually publishing data sets online through these data portals. So you can go to you can go to the like a website like data.cityofchicago.org, and we'll see if this comes up here. Okay, so the official City of Chicago data portal. And there's tons and tons of data sets on here, like towed vehicles and relocated vehicles and traffic tracking, food inspections, crimes, building permits, employee salaries, that's always a popular one here, abandoned buildings. And one of the things that you can find on here is pothole data. It's basically information from the city's 311 line. There's like an informational line where if you have like a big pothole on your street, you can call in and you can say, hey, you need to fix this pothole. So, so we can, yeah, okay, here it is. 311 service request potholes reported. So I actually have this data set. We're going to I actually provided it on the USB key so that you don't have to download this. But it's, I believe it's like 130,000 rows of pothole data from the City of Chicago. Okay, it's up to 140,000 rows. So it's a whole bunch of information about potholes. It has information in there like latitude, longitude coordinates. It has street addresses. It has zip codes. Even says what they did with it. How many potholes they filled on the block. They sent a crew and they found like, 80 potholes. I don't know if you can see that here. So there's like some street where they showed up and patched 80 potholes on the street there. So, so the challenge that we're going to do here is we're going to try to read this data set and figure out what the worst street to ride in Chicago is. So, so the slides kind of go through this. We're going to use the data, the portal there. It's about a 31 megabyte CSV file, 137,000 records, 140,000 records. To do this, it turns out to be not as hard as you think. We have to parse CSV files. Okay, it's comma-separated value files. The easiest way to do that is to use the CSV module and to use this feature known as a dict reader or a dictionary reader. It turns out that in these CSV files, they usually put a line of headers across the top of like what the names of the field are, and that will basically read the file into dictionaries that use those column names. Actually, let me show you a little example of this. Okay, so I'm going to open up a file. I think it's in data potholes.csv. I'm going to import CSV here. Okay, I'm going to put this sort of reader object around that, and then I'm just going to pull out one piece of data here. What you're going to get is it's essentially going to give you a dictionary that looks like this. So you're going to see things like, oh, it has like a status is open, X coordinates, zip code, longitude, coordinates, number of potholes, that kind of data. That's what it's going to look like. And so we're basically going to rip through that data and do some things with it. To tabulate data, I'm going to have to use a dictionary for that. One of the things that we're going to need to do is actually keep a table of like, well, where are the worst potholes? So we're going to go through this data set. We're going to collect a whole bunch of stuff. Anytime you need to tabulate stuff, use a dictionary. Dictionaries are great for this sort of stuff, like tabulating potholes by zip code, or tabulating potholes by street address, or tabulating by, you know, date, or anything like that. So what we're going to do is basically write some code like that. And then in addition to this, you might have to do some things with strings. One of the things that's in the problem is I actually, if you go back to the problem statement, I actually wanted you to find like the most pothole-filled 10-block section of road. Like, I don't want to ride my bike on like 1 block. I mean, that's not extreme enough, right? I mean, you know, I need like a 1 mile stretch, or, you know, a little big stretch of road. So you're going to have to do a little bit of hacking of street addresses to figure that out. I mean, there's a variety of ways that you could do that, but one of the things you could do is maybe take like a street address and then knock off like the last 2 digits or something. You could say, well, instead of 350 State Street, it's just like 3XX State Street, or 300 State Street or something. You're going to do something to kind of like make the address kind of spread out a little bit there. So, and then in addition to that, you might have to do some sorting stuff. There are some useful functions like min and max and sorted that can do that. You might have to look at the manual to just fully fix that. And then one last thing. If you start reading like real-world data sets, you might have errors, like missing values or corrupted values. You may have to do Python exception handling. So that's the last thing that you might need. Now, a question over here. Oh, really? On the on which? On the bus system? Or? Oh yeah. All right. How did we do that so fast? Did somebody? Yeah. Okay. Well, we're bad. Actually, if on the map stuff, there actually are some other mapping services out there, like. Yeah. 25,000 requests. You guys are good. You get bonus points for exceeding the API limit on the static lapse API. That's actually one problem with some of these online services. I do want you to get a key a lot of times to do more than. I guess they don't want people writing like the next, I don't know, like some huge web app that's going to send, you know, like 20 million requests into their free API. So. Interesting, we use that up. Okay, so anyway, I'm going to have you code. Basically, you're going to try to find the worst street in Chicago to ride your bike. 40 minutes. Now, I'm trying to think, when is the break in here? Is it right about, do you guys remember when the break is? Around 3? Okay. Okay. Code on this for a while. We'll go into the break, and then we'll have some time afterward. There's not, actually, the solution for this problem is actually not a lot of code. It might even be less code than the bus thing, but you have to think about it a little bit, because you're gonna be parsing through this data, and really the thought part of it more or less concerns this, the 10-block section of road in Chicago. That actually requires a little bit of thought, and there's actually some creativity involved with that. Here's the options on that. One thing that you could just do is you could just strip the address numbers down, where you could just say, you know what, I'm just gonna strip them down to like thousands, right? Okay, the 1,000 block, the 2,000 block, the 3,000 block, the 4,000 block, something like that. The other thing that you could try to do is try to find like more of like a sliding 10-block stretch, where you could say like, well, it's really bad between like 4,300 North Ashland and like 5,300 North Ashland, or it's really, you know, that one is actually would be more tricky. But, you know, see what you can do with it. It's 137,000 records of pothole. Okay. All right. You find me on the bus? So what's happening with those buses? Are they still traveling up and down Clark Street? Okay. So keep working on this pothole stuff for about 15 more minutes. Okay. Interesting, yeah. I'm gonna solve it by rounding off the street address. Pardon? No. I mean, you could probably do that, but I'm not sure whether I have time to do it. So. Oh, yeah, okay.
I could do
Ashland Avenue. It's definitely coming along. You just need the block number on it. Yeah. What?
Well, the first
What is inconsistent?
So if you have like a, you have an address like 952, but it's XXX.
Yeah.
And if it's 1952, it's 1XXX. So it's hard to differentiate between one. So it's a 1XXX and XXX.
Not that hard though.
No, it's not.
Yeah.
I'm just saying.
Uh-huh. Assume that the blocks start on like 0 and end on 99. Yeah, 100 addresses for a block. Yeah. Yeah. Contiguous on the same street. No, I want straight shot, 10 blocks down the same street. Yeah. No. Yeah, definitely. I'm not thinking about. Yeah, I'm not thinking about turns. Yeah, that would be. If you want to do turns, I won't stop you from doing turns, but that would be really. It would be interesting, but like a spiral or something. Yeah, a circle. Yeah. Yeah, you could do a U-turn back and forth. Yeah, no, we're just looking for like the 1,000 range addresses with most possible on the same street. So like.
But we don't want to just do 1,000 addresses and call that like a block.
You could. Yeah. Yeah.
That's a presumption. I get that.
Yeah. I mean, it's a rough. I mean, keep in mind that we're doing like quick and dirty hack here. You know, it's just like let's just 100 addresses per block, which is actually true. I mean, that's for Chicago is a grid system, so it's 100 per block and.
I can show you the block data for Milwaukee where I've got a listing of all of the starting building addresses for each side of the street. There's all the streets in the street, and most of them are 100.
Yeah, we've got some 50s and stuff, but yeah, this intersection to intersection. Yeah. Zero to 99 is a block. Yeah. So like 5400 to 5499 is one block.
So, is there like a set number of blocks per mile, north, south, and west?
Yeah, it's like I think it's 8. I think it's 8, but I think it's different on the south side and the north side. it is different somewhere. I actually saw a talk by some cartographer on this. It's, yeah. Yeah, let's not worry about long blocks, short blocks, or turns or anything, though. So. Or even distance. We're just talking like 1,000. Basically, what I want you to do is like just if like you see an address like 5412, just drop it down to like 5,000, and then tabulate that. Yeah. Miles, yeah. Yeah, I mean, one of the things in this problem, you can make this problem arbitrarily complicated for yourself. So it's. There are no bonus points, though. So you know, just.
Yeah, and I know.
Oh, very good. Is it getting closer or going farther away?
Well, it draws it only when the bus is there. So, isn't that what the instructions were? Was you wanted it to bring up a map
if it gets
when
within a
the
half a
bus
mile.
gets within a half a mile. Yeah. Right now, we don't have anybody within a mile.
Yeah, it's 2 miles. It looks like it's going further away.
And I have.
It looks like it got close and then drove further away. Actually, that's kind of interesting.
Well, that was an older one.
Oh.
So it's had some time. Also, I couldn't remember, was it only a positive distance?
Yeah, just, yeah. Yeah, yeah.
Within a half a mile, you're expecting probably travel.
Yeah. Right. Yeah. All right, I'm going to give everyone another 5 minutes to work on this. I'm going to give you a few other tools that will help too. So. Yep. No, request is cool. All those are cool. I'm not using it here just because I didn't want to make the install really complicated for a tutorial. So. All right, now if you're still working on that, let me talk about a few let me talk about just a few elements about how this exercise is actually working, or at least the different parts of it, or kind of break it down. One of the critical things in this exercise is we're using a dictionary as a tabulation tool. That's actually a very common use of dictionaries. It's that you use them to tabulate. And just to kind of break that down by, maybe sort of a simpler example where I can do this interactively. I'm basically taking like I'll make like a dictionary. Like maybe I'll just make this pothole by zip code. Okay, let's do something slightly different. Okay, so let's say I wanted to tabulate potholes by zip code. What you do is you sort of start with an empty dictionary, and then what you're going to do is you're going to just sort of accumulate data. So let's say you had, like you said, potholes, by zip code. Then you put in some zip code here, and then you want to do tabulation. This is what you want to do. You basically want to say, hey, I want to add one to that zip code. I want to add one to 60640. That doesn't actually work because it doesn't actually know what the first value is. Like you can't use this plus equals on something that doesn't exist. So we have a little bit of this hack where the initial value has to be set up first. Like essentially you set it to 1. This is kind of like the initial, and then once you've got that, then you can start doing this like plus equals business on it. Okay, so that's part of what's going on. Is you're sort of making a dictionary where you're like incrementing values, and like you're going to build this whole thing up, and then build this dictionary where you have like some key and then some values. That's actually what's happening in this block example, except that we have a much larger dictionary. I mean, we actually have this huge dictionary. I think it has like 875 entries in mine. I think something like that. Potholes by block. So 825 entries in there. And essentially the key is like some street address, kind of chopped off at the thousands place there. And then the number is the number of potholes. So what you can do is you can go in there and you could say, okay, potholes by block, and then you just specify an address like, 5XXXX North, Ashland Avenue or something. Say 1 pothole. Okay, so that's the thing that we're doing there. It's a little bit messy to to sort of set that up, but that's kind of the idea. Hopefully you're sort of seeing how that works there. Everybody okay with that? Questions about that? Very common use is use dictionaries, like basically a tabulation tool. The key is basically like a street address or a zip code or something. Yeah, question up here. Exactly. Now his question is about sorting dictionaries. I am an evil person for giving you this problem, asking basically to find like the 10 worst potholed streets in Chicago. It turns out that a very common question that comes up in doing Python data handling is people use dictionaries to do this like tabulation stuff, but then they want to sort it afterwards. And a big problem with dictionaries is that they don't store anything in sorted order. There actually is no sort method on a dictionary. And then it's even more complicated than that. Like actually, let's say you had this potholes by zip. I'm actually just gonna fill this in manually with like a bunch of values. So let's say you had a bunch of zip codes here. Like different kinds of zip codes, counts of potholes, and so forth. Things like that. If you want to sort that, it's actually an even nastier, trickier problem because you could sort it in 2 different ways. Like one of the things that you could do is you could say, oh, I want to sort it by the zip code. This is actually what would happen if you said sorted potholes by zip. You would actually get a sorted alphabetical listing of the zip code. 60615, 60637, 60640. That is almost not ever what you want in a data tabulation problem like that, because that's not it's not ranking them by the pothole count basically. So if you want to do the pothole count, it's like essentially you're sort of tangled up in this mess. Like you could basically get like the keys of the dictionary. There's a method keys, by the way, that will tell you the keys. You could sort that, which is what we just did. You could do a sort of the dictionary values. If you do values, you get like the values in the dictionary. But this also turns out to be sort of useless. Like if you do a sort on that, okay, you get the sorted list of the potholes, but then it doesn't tell you the zip code that it came from. So it's like you lose like the interesting piece of data. So I'm a little bit of like an evil person for throwing that at you without any explanation in the exercise. This is definitely the trickiest part of it, is like, well, how do you sort that data? There's a couple of different approaches that you could take here. One of the things that you could do is basically turn it into a list. I mean, actually, if you want to sort something, you have to turn it into a list, because that's the only thing that you can sort. You could do something like this. You could say for key and potholes by zip dot keys, append basically the you'll see what happens here in a second. You could do something like that. This is what this is doing, is making a list of tuples where the number of potholes goes first and then the zip code goes second. If you do that and you sort it, it turns out that it will do what you want. What happens is, if you sort a list of tuples, Python always looks at the first value first, and then it goes to the second value. So this will actually sort by the number of potholes first. So it goes 13 there, 21, 23, 123. Yeah, if you want to do reverse, there's just a flag on it. So you just say reverse equals true, then it would go backwards like that. Okay, so that's one way to do that. Another way that you can do it, this is sort of getting a little bit ahead in the notes, but I'll sort of throw it at you anyway. You might see people doing, like, they would say sorted potholes by zip, and then they would specify what's known as a key processing function using the lambda operator. I sort of apologize for this, but they might do something like that. What is actually happening there is like lambda. God, what happened here? This key function. What lambda is it's a way of writing like a little one-line function. Like you could write a function like get number of potholes, where you pass in a zip code, and then what it would do is you would return, potholes by zip code. So the idea here is you have some function where you pass it in like a zip code, and then it tells you how many potholes are in the zip code. Okay, so you have like this function that's doing a lookup there. It turns out that you can pass that to the sort function. Like you can say sorted potholes by zip, key equals get num potholes, and it'll sort of rank these things by the total number of potholes that they have. Okay, so if you look at that data, the best or the
That is the simplest way to explain it, and the most clearest way I've ever heard.
Oh, okay. Yeah, Lambda has sort of a weird, like, sorted history with Python, but it's by far the number one use of Lambda is to avoid having to just like write out like a one-line function like that. I mean, it's like you could write like a one-line function, but the Lambda is a way of inlining it. I mean, it's kind of like this lambda k. K is the input key, and then this is the return value. Now, question over here. So. Oh, you're okay. So. The lambda operator, by the way, I think probably I would say like 90% of the uses I've ever seen for it in practice are with the sort function. I mean, the other thing too, by the way, I don't know that you knew this, but you can also use the key function with the min function too. like min and max. What that's doing is basically giving you the minimum number of, it's giving you the key that has the minimum number of potholes. But yeah, so a little bit evil throwing that at you there, but that's, I don't know. You got to have a little bit of evil in a tutorial at PyCon, so it's you know, little bit of stuff there. Now some of the other stuff I'm going to throw at you here is I need to give you some power tools here. Brian's going to give me hell for showing the picture of the power tool. I've been quite interested in power tools lately, so there's a Python-powered power tool there. So if you're going to do any serious data processing stuff in Python, you have to know some tricks of the trade. And I would say the #1 trick that I think you should definitely get a handle on is the list comprehension feature. If you have not seen this before, it will change your life. You will write all code using it, and you'll get fired because nobody will be able to figure out your code eventually. Okay, so, but the gist of it is, let's say you had like a list of numbers, 45, 13, things like that. Let's say you wanted to just apply some operation across that. Like let's say you wanted to square all the numbers. You could do it manually. Like you could say, okay, squares is equal to empty list, and then you could say for x and nums, squares append x times x. And you would make a new list. This is a very common thing in data processing. You take a bunch of data, you apply some operation across it, you get a new list of data. It turns out that is so common that you can just shortcut it. You can just say square bracket, like you could just say squares is equal to square bracket x times x for x and nums. And it would just do the same thing. I mean, what it's doing is it's just collecting the result of doing that across that list, and then it would, you know, sort of give you that data. You can also do a filter on this. So you could do like x times x for x in nums if x greater than 0, for instance. That would basically discard the negative, like the -5 would not pass the test and like get discarded in the result there. So you can put a filter on that. And this feature of the language, if you really get a handle on it, is massively powerful for data processing stuff, because it almost takes like Python list processing and basically marries it with the kind of stuff that people would do with databases. So, you know, like just as an example, these are some queries here. I could do something like this. Here's sort of an example. I could open up. Let's open up that pothole database. Okay, so we're going to open up potholes.csv. What I'm going to do here is I'm going to just make a list, and then I'm going to take all potholes. Okay, actually I'll just say potholes is equal to a list of CSV dict reader of F. Okay, so this is going to read like that entire 140,000 line file into memory here. Okay, 139,000 records here. So reads the whole thing in. I could actually start processing that in various ways with list comprehensions. Like let's say I was only interested in potholes on Clark Street because I want to have a smooth bus ride on Route 22. Okay, I'll merge the two the two problems together here. I could basically come in here and I could say, let's like Clark potholes is equal to, hole in potholes. If this is going to be kind of a hack there. If Clark happens to be in whole like street address. Okay, this is like kind of a gross hack. But what this is doing is like going over all the pothole records and saying if the name Clark happens to be in the street name, I'll just collect that. And I have a syntax here. Whole for, oh, it helps if you actually use the for in there. Okay. It almost looks like a database query. Okay, so you could write something like that, and then you could say, okay, well, what happened there? It's like, oh, okay, 700 pothole reports on Clark Street. It basically took like that 139,000 data set and just reduced it down to that. I could do other things like, just like let's rip out the addresses on that. Like let's just give me like the whole address. Could do that, and then I would end up getting just a list of all the addresses. So it's like it took that data and just sort of reduced it down just to street addresses. Tons and tons of really interesting things with list comprehensions. I mean, this is only a very small taste of that. 10 more times slowly, yeah. Just see that there. You'll get a chance to play with this in a second, but yeah, it's essentially just going through and saying, okay, give me. Collect all the street addresses off those pothole records. It might take a bit of time to kind of fully appreciate that, but it's very cool. And then another thing that is really, really useful for data processing stuff is the collections module. Collections is probably the single most useful library in Python for doing data structure kinds of stuff. There's tons and tons and tons of interesting things in there. And one of the more interesting ones is this counter object. Turns out that counters do tabulation. It's actually an object for tabulation. And this, just to give you an idea of how cool this is, I could do something like this. I could say, I just have this list of 139,000. I have 139,000 potholes. One of the things that I could do is I could say, okay, you know what? Give me all the addresses. So we're going to collect all the street addresses for all the data there. Basically, so what I'm doing here is if you look at a couple of these, I've just taken like all the street addresses. Okay, so you have all the street addresses there. If I wanted to tabulate those into like a table, like the counts, I could say, okay, I could say from collections import counter, and I could just say, okay, like tab is equal to counter of addresses, like a one-line thing. Okay, so I just basically built that. That actually did the exercise that you just did in like one line of code. Okay, and then what you can do is you can say, you know what? Okay, give me the most common addresses, 10. It'll come up and do it. It's like, okay, 4700 Lake Park Avenue, 108 records, number 1. Okay, so it's basically doing the tabulation for you. Really cool. I mean, you have to look at the documentation for that, but this counter object it's like this data tabulation stuff that we did is so common that it's just in the standard library. Very cool. How many of you have actually seen counters before? It's a couple of you. I think it's like an overlooked feature. Another thing that is useful. Okay, I actually talked about advanced sorting. So this is you sort with the key function to do that. There are some other things that are useful as well. One of the things that you might want to do is data grouping. This is actually a tricky problem with these data sets where you can say, okay, I have all this pothole data. I want to group it according to like date or something like that. I want to take one of the fields and then do like operate on it according to groups or clusters of data. There are some libraries like this iter tools that have functions for that. Like there's a group by function in there where you can just hand it a bunch of records along with like a key function, and what it will do is hand you chunks of records that are grouped by whatever that key is. So that's also kind of a neat thing. Maybe I'll do a demo in a second of that. The other thing that might be useful is to do what I'm calling index building as well. Let's say you had this. Okay, let's say you had this this huge database of potholes, 139,000 potholes, and you wanted to be able to do indexing by like zip code. I don't know, maybe you're making like some mobile pothole app or something like that, and you like know where the person is with their phone, like what zip code there is, and you want to like quickly be able to find all the potholes in that zip code. What you don't want to do is you don't want to search 139,000 pothole records every single time somebody does a zip code search. So it turns out that there's another object in the collections module, this thing called a default dictionary. from, yeah. I lose 10 points there. Okay, so so you do from collections import default dig, and then what you could do is you could basically make an index. You could say like zip code index is equal to default dict list, and what this is going to be is it's going to be a dictionary that basically collects like multiple results for you. I mean, here's how this would work. You could put like you would just say, okay, 60640 append, you know, like 10 or something. I'll do a real example in a second. But what you do is you just like, you use a dictionary, kind of like a list where you're appending things in there. And what it's doing under the covers is it's kind of collecting all these entries. So you can see over here, it's like, oh, 60640 has 10 and 15 in it, and 60637 has 23 in it. What you can actually do with this for real is something like this. You could say, okay, let's do like for hole in potholes, zip code index, where you would like look up the zip code. Actually, I don't remember whether it's zip or, well, I'll try that. Is it zip? Okay. Append hole here. Okay, so what I'm going to do is I'm going to rip through that data set, and what I'm doing is I'm basically taking the zip code out, and I'm using that as kind of an indexing value, and it turns out that now this zip code index lets you do quick lookups. Like you can just say, okay, go to 60640 and give me all the pothole records on that thing. What did I call it? Zip code, okay, len. Okay, so 1,700 records for 60640 and 2,300 for that. It's basically doing like indexing or binning, actually another way would do it. You're taking all the data and you're like dropping it into different bins so you can actually find it quickly. So that's another tool to use, basically that. If you want to take this more advanced, there are a lot of third-party libraries that will take this even further. Some of the scientific libraries like NumPy, Matplotlib, Pandas, and so forth. Just as a quick demo of that, for doing a lot of this data analysis stuff, you should definitely look at the Pandas library. This is a third-party library. But what you can do with that is you could just say, okay, potholes is equal to pandas.read.csv, data potholes.csv. Okay, so it actually has a CSV reader in it. So you can read that stuff up. It will sort of summarize data for you. So it will, instead of printing out like all 139,000 records on the screen, it will sort of tell you that's like, okay, here's a little summary of the data. You can even do these like really quick calculations. Like you could say potholes, zip, you know, value counts. Like, you know, give me the first top 10, like top 10 ranking of zip code pothole records or something like that. Basically taking like some of the stuff that we just did and like just reduce it down to just not, you know, like just a few statements. So very powerful stuff up there. This is not a Pandas tutorial though, so I can't really. I'd probably dig a big hole for myself here. So. Yeah, you don't need to know anything. You just import pandas. Yeah. So the final thing we're going to do here, see how we're doing on time. Pies. Chicago theme. Got to have pizza. You know. So the problem here, very hungry after all that biking on the potholes here. You know, but food safety is nothing to mess around with, right? You know, you don't want to get food poisoning or anything like that. So what we're going to do here is we're going to try to analyze the Chicago Food Inspector Health Department database of basically restaurant and grocery store inspections. And the challenge here is basically to see whether you could make I don't know, maybe make like an infographic or just some kind of breakdown of like what that data contains. There's a ton of data in there. It's basically a 77 megabyte file. Some of the stuff that's in there is pretty interesting, actually. They actually tell you like who passed, who failed the inspection. They actually have the inspector notes in there saying, oh yeah, there's rodent droppings and you didn't clean this stuff. There's like a ton of stuff in there. all sorts of new challenges. It has like, risk levels. What kind of establishment was it? Was it a school? Was it a grocery store? Was it a restaurant? Was it a bar? Was it open? Was it closed? Were they denied entry? That sort of thing. So interesting data in there. So this is a little bit open-ended. I'll do some stuff to start, but the challenge is to take that data and see whether you can do something like maybe make a pie chart or something using matplotlib. If you've never used matplotlib, this is library lets you do pie charts and things. So let me see if I have that installed here. You can do things like make a pie chart, and then you give it like the percentages, like 23, 47, 25, 15, 10. And then we'll see what it does here. Okay, so it's a library where you can make charts pretty easily. I think there's a code sample of that I give you that you can use that. Another thing that you might do if you're feeling really ambitious about this would be to try using IPython Notebook project. If you've never encountered that before, it's actually pretty cool. It's Python basically running in the browser. Let me just go here. So what you would do is you would do IPython Notebook minus, well, like Pylab inline or something like that. This is something that you may or may not have installed. If you do not have this stuff installed, I've actually given you some distributions on that USB key that have this stuff available. Basically, this IPython Notebook, it's Python running in the browser, and you can do different calculations. Like you can import pandas. You could do potholes is equal to. You could do all of your usual calculations here. I've actually seen a number of you using IPython just walking around. So some of you have already seen the magic on here, but. Okay, so you can basically run stuff in the browser. One of the cool things about this is you can actually go up and change things later. Like if you wanted to change this instead of zip codes, you could come up here and say, well, let's rank it by street address, and then redo the calculation, and then all of a sudden it changes to ranking by street address. So a lot of neat things there. And then the other neat thing about it is you can do these, you can do graphing directly into in the browser here. It will show you pie charts and plots and things like that. Again, this is not meant to be an IPython tutorial, so I can't give you tons and tons of information about it. But essentially the final challenge here would be to see what you can do with the restaurant data. Now there's a whole bunch of angles that you could take on this data. One angle that you could take is you could find out things like which restaurant in Chicago has the most violations. This is kind of a dangerous angle of inquiry, right? It's it does record restaurant names in there. You could find out what's the worst place to eat. You could find out if you really want to challenge, you could find out what is the most common code violation that is actually given to a restaurant. That actually information is in there. So you could say, well, if I'm opening up a restaurant, what is the most likely thing that they're going to cite me for out of this municipal code? That data is actually in the CSV file. They actually have it broken down by code violations of different things, like you don't have clean surfaces, or you're not storing food at the right temperature, or anything like that. So you could look at that. You could look at pass failure, breakdowns. There's a variety of sort of angles on it. So I'm going to have you look at that. Use your creativity here for a few minutes, and I'll make some comments at the end. I'll do a few examples as you work on it here. So let me just see if there's any questions about anything before we jump into this. Probably nobody will want to come to Chicago after they see the food inspection today. So there's IPython, Notepad, -- yeah, you do IPython Notebook minus Pylab inline. The last option there is to enable the graphics, basically. Yeah, PyLab equal inline. If this IPython thing does not work, you could see if you could get it to work. Probably the easiest way to do that is to get the USB key, find that installers directory, and there's a couple of things. There's basically something known as the nthought Python distribution, free, which is in there. There's also Anaconda, which is a distribution. It saves your stuff, yeah. Okay, so work on that for a little bit here. I'll walk around, see how people are doing. You type in a command like, print hello world or something. Actually, you can type in multiple lines. I mean, you can do a bunch of code, and then probably the tricky thing is, in order to get it to run, you have to hit Shift Enter or Shift Return. It's a little bit.
You do Control Enter and stay in the same cell. Shift Enter.
Yeah, in the next cell. So you have to either hit like Shift Enter or Control Enter to get that to run. If you want to go and edit the thing, like change it to a different value, or you can just go up and hit Shift Enter again or Control Enter, and it'll redo the output of that. So. What, the bin 30, the wine place?
Yeah, exactly.
Why did they fail spectacularly? Okay. All right. Here's one of the challenges of this data set, by the way. So to do this problem, this is actually what I would recommend to start. It's basically read it as CSV. I would turn the whole thing into just a huge list. So let's just make a list of all the food inspections. Now, I don't remember how big that is, but I think it's probably pretty big. 58,000 records of inspections. Okay, so that's what that is. The interesting thing about some of the data. Okay, so here's what you get. You get kind of the business name. You get address, doing business name as. Those are often different. Like sometimes these are owned by like LLCs and Shell Corporation. Who knows? But owned by different things. It'll tell you like is it a restaurant? When was it inspected? Inspection type, complaint, whole bunch of things, and then you get results. Like past is that, but some of the things that's encoded in here is actually, this is the really interesting part to deal with. Is this? If you look at the violations, it's like okay, that's kind of interesting. It's like a big text block in there talking about what in the world, like what happened in their failed inspection there. If you want to challenge, you might try parsing that as text. And what you could do is you could say like, let's see, what did I print out there? I printed out, okay, that was food entry 2 there. You could say, you could do like food 2, let's just print out what that is. Okay, so there's basically what the violations look like. You might be able to process that by doing some kind of clever string splitting or something like that. I mean, this is more of a heuristic, but if you look at it, it looks like the different violations are split by this vertical bar. So like 40, 41. The number there is actually, I believe, a number in the municipal code. So there's actually a municipal code regarding restaurant inspection. So they're citing them. Violation of section 40 of the restaurant code, refrigeration and metal stem thermometers. Okay, so what you might be able to do is take something like that. Here's sort of an attempt at that. So let's say V is equal to food to. I'm going to pull this off here. So violations. You could make like a list. You could say V list is equal to V split on that vertical bar character. Let's take a look at that. What that's going to do is basically isolate this down. So now what we've got is we have a list like, okay, violation 40, 41, 38. Maybe you would be able to parse that a little bit further. It looks like the comments might be something like custom, like the first part of it is maybe like just a general name of the code violation, and then after that there's some comments from the inspection. This is definitely more like probably the more challenging part if you want to tackle this in this problem is like, could you do a ranking of all the restaurant code violations to find out what is the most common code violation, period. Is it rats and rodents? Is it unclean surfaces? Is it storage temperature? It's like, actually it seems like all the high-end restaurants in Chicago are always getting in violation of like food preparation temperatures, because they're always doing exotic preparations, you know, uncooked meats and all sorts of crazy stuff, so they're always getting cited. So keep working on that a little bit. See what you... It's making you hungry too. You can do the value counts thing. Here's sort of an interesting value count. Like what you could do here is you could do the doing business as name, DBA name. So you could say from collections import counter. You could do something like this. This is basically tabulating like how often a doing business as entity in the database is appearing, and then you could do something like this. This might tell you answers that you don't want to know or what you wish you had not asked, basically. But you could find out like the 10 most common inspected restaurants in the city there. This is actually just telling you who got inspected the most. So I don't know how much to read into that. Probably what you would read in that is that you're kind of ranking by the most common like franchises in the city. So there's like a lot of Subways there. If you wanted to filter this down a little bit further, you could do you could look at the results. Or actually just check if it failed. Yeah, I don't know what's going to happen with the most failed inspection. Did anybody do that? Yeah. Yeah, that's what you're seeing there. Is just like probably, yeah, more of them. How far up do you want to go? You want to go? When this data set was first published by the city, about 2 weeks later in the Chicago Tribune, there was an article talking about how Chicago's 3-star Michelin restaurant had failed its health inspection, and I'm pretty sure that they got the data from this. I think they failed for like improper food temperature or something like that. Or are you doing a search for rats? Yeah. So believe it or not, we're actually almost out of time. We have like 7 minutes left in this tutorial. I wanted to make a few final comments. If you're still working on that, if you look at the violations, I mean, basically I found that the most common one was related to floors, it seems like. So either clean floors or something like that. I have to admit that probably the greatest concern that I would have for a restaurant would not be the most common violation, but would be the most uncommon violation. And that's kind of, maybe that's just me, but like if you go to the other end of the list, you get into things like personnel with infections or something like that. That would be the one that like would want to sort of, sort of stay away from that that place. Although fortunately there's only one record with that, so interesting things here. So a few final comments on the tutorial here. I mean, if you're looking at this and sort of where to go from here, you could certainly get into sort of much more deeper Python coding, like functions and modules and classes and so forth. There's a lot of really interesting data analysis stuff going on with sort of NumPy, SciPy, Pandas, IPython notebook, and all sorts of things like that. Tons of interesting stuff with some of these, like the data sources. The cities are publishing this data. There's a lot of things with crime data, with census data, traffic data. Tons and tons of stuff is getting out there. Actually, some of that, there's some of the reasons for putting that data out there is really interesting. Like I know in Chicago, they're publishing a lot of this data because they're trying to avoid Freedom of Information Act requests, where they're just like, people would submit like a freedom of information to the city, and it's like, they can tell people, it's like, well, just go to the data portal, look it up. Just make it available. A lot of interesting stuff there. So, final comments. Thanks for coming. I hope at least you had some like fun messing around with stuff. If you didn't get all the problems, it's no harm there. But at least see some interesting things with data sets and things you can do with Python. I will put some of the solution code online, some of the stuff that I've coded. It's not a lot, but I'll put it on the website for the course. So I know that there's going to be some evaluations given for the tutorials. I don't remember. I think those are online somewhere. Fill them out. Let me know what could be better. This is, again, kind of an experimental tutorial. See what happens. So, all right. So that's basically it. We have maybe about 4 or 5 minutes left. So I'll kind of hang out, see what people are doing here, and. Again, thanks for coming. So. Unix machines and so forth. If you're going to use the idle tool, just a note about that. It's a little bit unusual, but typically what you do with that tool is you will make a program by kind of coming up here. You basically say, hey, I want to make a program, file, new window. You get a new window where you put your code in here. Okay, so there's some Python code. In order to run that, what you need to do is basically save it as a Python file. Okay, so you're going to do save as. It will sort of prompt you for a file name. Go up here and just say, hello.py. And then in order to run that, and this is kind of the unusual part, you need to find the run button in idle, and then come down here and click run module. So that will essentially run the program, and you'll see the output in the terminal window there. So it's a little bit different than what you would do just running it on like a Unix machine or something like that. But if you are going to use idle, that's how you do that. And so that's some basics of making programs. Now, what I'm going to do next, let me just see if there's, I don't know, is everybody okay with kind of running Python and starting it up? I would assume so if you've seen it before. What I'm going to do next is a very, very, very fast Python 101, because what I want to do is get through some basics and actually have you write some code for something more interesting. So let's just let's get a few basics out of the way. First of all, the structure of a Python program is just a bunch of statements, one after the other, terminated by new lines. The way that the interpreter works just starts at the top of your file and goes top to bottom, and when it hits the bottom of the file, that's the end of your program. So it's very much like a scripting sort of model. If you want to have a comment, use a pound sign. If you want to assign a variable, just assign a name to some value, like height is 442 or name is Dave or something like that. Okay, so just a variable name and a value. If you come from other programming languages like Java or C or something like that, you don't declare types. Like, so you don't say like it's an integer, or you don't say that it's a float or anything like that. The value basically, or the type basically comes from what you assign it. Like 442 is an integer, for instance. There are some basic data types that you work with in programs. For numbers, there's basically integers and there's floating point. How you would specify that in a program is just with the decimal point. So if you don't have a decimal point, it's an integer. If you do, it's floating point. If you want to work with text, you just enclose text in quotes, either single quotes or double quotes. There is no difference between single quotes and double quotes. So use whatever style you're happy with, basically. So there's two different quoting styles. None is something that you'll see as a placeholder. It just means nothing. It's like, oh, this is a variable, it doesn't have a value of interest right now. So those are some of the basic types. If you want to do math, Python behaves normal. Is just get some basics out of the way to start. So the first thing is just running Python. I mean, hopefully you've figured this out at this point, but to run Python, typically run it from the terminal. Just type Python, get a prompt, you start typing commands into it. If you are on a Windows machine, how many of you are using a Windows machine in here? I would probably advise, unless you have some alternative on there, to use idle to get started. I mean, unless you have some other environment installed, because otherwise you're going to have to run Python from the DOS, like the command prompt, which sort of sucks, actually. Okay, so if you're on a Windows machine, you should just be able to go to, like the Start menu. If you have Python installed, you should be able to just find the idle program, run that, and it will bring up the Python interpreter for you. And you should be able to do pretty much everything in this class just from the idle interpreter. Okay, took a little while to come up there, but you'll get this terminal. You can type commands into it, do math calculations and so forth. Okay, so Python basically, if you're new to it, is an interpreted language. It executes what you type. You have this interactive mode. Very fun. If you've been playing with Python already, you should know this, or you should have seen this. Some things about that interactive mode, it does just sort of run what's known as a read-eval loop. It's actually one of the coolest things about Python is that you can actually experiment with it. You can fire it up, you can type commands into it, just do immediately what you type. I think it's one of the neatest features of the whole language is that you can just do this interactive exploration with it. A few little notes about the interactive mode. Triple greater than is just the prompt, Python telling you, hey, type a command. If for some reason you get triple dots or blanks and it's not doing anything, it usually means that it wants you to keep typing what you started. It's like saying, oh, well, you're on it's multiple lines, you need to keep typing. You do that and then you hit a blank line to get it to run. As far as creating programs to run later, all you need to do is just create a .py file using whatever your favorite editor happens to be. I mean, hopefully it's called Emacs, but if not, you're giving me a look, Brian? With the, okay, yeah, it could be something other than Emacs, but just make a file with whatever editor you want to use, and then to run a program, you just run Python on it. You basically say Python hello world.py runs your program. Okay, and that works on Windows, works on Unix, and so forth. One little pro tip that I'm going to leave you with for exploration. I'm a big fan of using the Python -i option with a program. Like you edit a program and then you run Python -i on it. That will actually run your program and then drop you into the interactive term, like the shell, and then you can mess around with it. Very useful for debugging and doing things like that. So if you haven't seen that before, that's actually a very useful technique. Sort of two constructs for that. There's a while loop, which basically just executes in the indented statements under there as long as some condition is true. And then there's a for loop, which is used to iterate over data. Okay, so this is like if you have a list of names or something like that, the for loop will process those one at a time, going over data. Just a few notes about some of these things like conditionals and loops and so forth. You will notice that Python uses indentation to basically denote code blocks. like the statements that are going to execute. Just so you know, the amount of indentation does not matter. However, at this conference, you'll be bludgeoned if it's not 4 spaces per level. So, you know, typically what you do for indentation is use spaces, don't use tabs, use 4 spaces per level. If you use an editor that knows about Python, usually it does this for you. Okay, so that's the indentation rule. For doing output, use a print statement. Well, produce output. This is one big change between Python 2 and Python 3. If you use Python 3, print changes into a function. So be aware of that if you're going to use that. And then a few little final odds and ends. If you want to work with files, which we're going to do actually a fair amount in this class, you use the open function to open up a file. Okay, so you say, okay, I'm going to open up some file for reading or writing. To read or write data, there's a read method and there's a write method. Read will basically just take the entire file and just grab it and put it in a text string and then hand it back to you. Write will basically take data and just write it out to a file. Another idiom that's very, very common with files is reading one line at a time. Typically you do that by opening up a file. You do a for loop on it, and then you just go line by line. It'll basically read that until you get to the end of the file. So those are some idioms with files. And then a couple final things. Sometimes you might want to define a function to do repeated operations. If you want to do a function, you just use the def statement. You say, okay, def, name of a function, some input arguments. This becomes something that you can then just use in your program. Okay, you just use the name of the function, and it will just call that and return some data back. Believe it or not, this is about the only thing I'm going to say about functions in this class. It turns out that functions, for the most part, are actually quite uninteresting in Python because they actually work normally. Like, they behave in a sane way in that, like, they have, you know, like variables have like, there's like local variables that are hidden and the naming works and all this stuff. You just don't worry about them a whole lot. But this is how you define new function, basically, with the def statement. And then if you want to use built-in functions, there's basically an import statement that is used to load library. So Python actually comes with a large library of code for doing things like math and reading from the web and doing data analysis, that sort of stuff. And this is kind of an experimental tutorial. It's about learning Python, but not through like a hello world program or Fibonacci numbers, okay? So it's basically going to combine sort of a learning Python tutorial with some public data hacking examples. And just to help me out a little bit, I don't know what experience with Python people have in the audience here. And not to put anybody on the spot, but I would be sort of curious, how many of you feel that you're sort of new with Python, kind of sort of new with Python? Okay, about two-thirds, okay. Is there anybody who's never done anything with Python at all, like never started it? One person, okay. It's your responsibility to help him out there, okay. So it's good that everybody has done that. The version of Python for this course, everything should probably work with 2.7 or 3.3. I'm going to use 2.7 just because I'm going to do some plotting later, and the tools are installed a little bit better for that. Again, there are some support files kind of going around on USB key. There's not a huge number of support files, just so you know what that looks like. Let me sort of find the files here. You should have a folder. It looks like Learn Python Data. There should be a code directory. There should be a data directory. PyData hacking is the presentation notes. So if you want to look at the PDF of what I'm going to present, that's where you'll find that there. And then that's about it. I'll talk about what's in there as we go, but that's what's on the USB key, and you'll need that. As far as what the tutorial is going to cover, it's basically 2 topics: learning Python and hacking some public data. The primary focus is on the Python side, just to be absolutely clear about that. I mean, it's like the title of the talk was learning Python, not learning data, okay? So it's about learning Python. We're going to do a lot of coding. Later on in the tutorial, I'm just going to let you loose for like half an hour, 40 minutes. We're going to code on like some hacking problem involving data. And I think you'll have fun with that. One note, it's the focus of this tutorial, again, is not on data science, okay? So we're not going to be doing statistics in here, or GIS, or advanced math, or Hadoop, or anything like that. I mean, this is not like a big data tutorial, basically learning Python. And we are going to do a fair amount of coding, so do introduce yourself to your neighbors, like look at who's sitting next to you, work together when we get to the coding section. And then your responsibilities here, ask questions, don't be afraid to try stuff out. I might actually, put a little bit of a burden on you in reading the documentation. I don't want this course to be a reference manual on Python. So I'm not going to sit up here and tell you like every single possible thing about everything, okay? It's, you might have to look a little bit at the docs. And then get my attention if you're stuck on anything. I've also got a couple of assistants. Brian is in the back, sort of standing back there. We have Jake is going to do some stuff as well. So ask questions. And so why don't we just go ahead and get started with it. So the first thing that I'm going to do, I mean, we could talk more about that, but Python is not violating like the rules of algebra or anything like that, okay? You just do normal math operations. There is one potential gotcha for doing data calculations, which is the fact that integer division truncates. So be a little bit aware that if you're doing any kind of calculation, like 7 divided by 4, it's going to drop down to 1 and not give you 1.75. So that's one little caution. If you want to do text manipulation, generally what happens with that is you make a string, and then there's operations like len and plus and upper and starts with and replace and so forth. Just as some maybe an interactive example of that. Well, I don't know. We'll stick with Windows here. Why not? Okay. So let's say you had a string like "Hello World," for instance. If you wanted to do things with that, len will tell you how long it is. If you wanted to add something to it, like add an exclamation point, you just use the plus. We'll like add a character to it. There are various operations like. You can uppercase it. You could replace things, like you could say replace hello with hello cruel, for instance, and so forth. So strings basically have a bunch of these operations. This course is not really going to be a quiz about the 36 things that you can do with strings, though. So this is just sort of a taste of it. I mean, of what's available. Basically doing string manipulation. Sometimes you need to convert values. This is actually a slide that is actually it's actually critically important for a lot of data analysis stuff. If you want to do like math calculations, you have to make sure that things are of the right type. Just to illustrate that, let's say you had x was equal to 42 in quotes. Okay, this is a text string, and then let's say you had y was equal to 13. You can't add those together. Okay, I mean, because one of them is basically a string and the other one's an integer, and it's getting very confused by that. So if you want to do anything, sometimes you'll actually have to do conversions. Like you'll have to convert one of them to an integer and then do math with that. Just as a quick question regarding fonts, by the way, how's the readability back there in the corner? Is it like, okay, could be a bit better maybe, okay. I'll sort of bump it up when we get going into the code stuff. So you might have to do some conversions, and then some other things in programs. If you ever want to do a conditional, just use if and else for that. Okay, pretty straightforward. That you see that in most other programming languages, if and else. If you want to do relations, it's just less than, greater than equal. Same kinds of operations that you have in other programming languages. If you want to do Booleans, you just do and, or, and not for that. Okay, so those are some conditionals there. If you want to do looping,